how to calculate the real exchange rate, or rather, an index of the real exchange rate. The formula that we are going to use is that the real exchange rate is E, the nominal exchange rate, multiplied by P star, the foreign price level, divided by P, representing the local price level. This is actually intuitive as a representation of the real exchange rate. The numerator, the nominal exchange rate multiplied by an index of the foreign price level, is the cost of foreign goods in local currency. The denominator represents the cost of domestically produced goods. So this ratio is the cost of foreign goods relative to local goods, and they're both expressed in the same currency. Let's do a calculation. Suppose the nominal exchange rate is 4-1 and the US price level is represented by $1. The average price of everything in the US is $1. In practice, what you would use as P star is some index of the US price level, like the consumer price index in the US. And in the denominator would be a price index representing local prices, the local consumer price index. Let us say that that is 2. If you do that calculation, you're going to get a number that represents the real exchange rate, but the cardinal value of the number is meaningless. 2 is just an index number and doesn't represent any actual value that has meaning. Our index of the real exchange rate becomes useful when we try to track how the real exchange rate changes over time. So, for example, suppose there is inflation in the US. US prices go up by 50%. So our index of US prices goes from 1 to 1.5. When we calculate the new real exchange rate, we get a value that is higher than the one we had before, 50% higher. So that tells us that we have had a real exchange rate depreciation of 50%. The interpretation is that foreign goods have become more expensive relative to local goods when both are expressed in local currency. What about in the case that there is local inflation but not foreign inflation, that prices are stable in the US and the nominal exchange rate remains stable? Let us say that local prices double. So the price index of local production goes from 2 to 4. Well, then our calculated real exchange rate goes from 2 to 1. This is a real exchange rate appreciation. The interpretation is that foreign goods have now become cheaper relative to local goods. So the implication of this, taking both of those exercises into account, is that we can know what is happening to the real exchange rate by simply comparing the rates of inflation in the two countries, in the two currency areas, as long as the nominal exchange rate, represented by E, is constant. If the nominal exchange rate doesn't change, for whatever reason, then if local inflation is higher than inflation in the US, then that tells us that over time, foreign goods are getting cheaper relative to local goods. And that's a real exchange rate appreciation. Once local prices are rising faster than foreign prices, and the nominal exchange rate is not adjusting commensurately, then foreign goods are getting steadily cheaper, and that is the real exchange rate appreciation. So this is the formula that you can use to calculate an index that will tell you how the real exchange rate is changing over time. So we have derived an index series that can reveal how the real exchange rate changes.